Hello everyone, I welcome you all in the C Programming and Data Structures lecture. This is part 2 of program 2, that is prime factors in descending order. In this presentation, we will try to write a program in order to find the prime factors of a given number, and we will also print all the prime factors in descending order with the help of a stack. So without any further delay, let's get started. Here you can see that we are interested in finding the prime factors of this given number, right? 450. And these are all the prime factors of this number, and we have found out all these prime factors with the help of prime factorization technique. We have learned this in the previous presentation, right? If you haven't watched the previous lecture, then I would recommend you to watch that lecture before moving on to this lecture, okay? Here you can see a stack is given, and in the stack all the prime factors are placed. 2, 3, 3, 5, 5. And eventually we'll get this output 5, 5, 3, 3, 2, because we will pop all these elements from the stack one by one, and obviously this element will get printed first, then this element, and so on, right? Therefore the output must be 5, 5, 3, 3, 2. Actually, the stack is helping us in printing all the prime factors in descending order, as it can be observed from this particular example, right? Now we will try to write a program for the purpose of getting this output. We will actually move with this example and we'll try to write a program in order to find all the prime factors of this particular number. Okay, and then that particular program is capable enough to find prime factors of every possible number, and it will also print all the prime factors in descending order. Let's try to write the program for the same. Here we need a separate function called prime fact. Okay, this is just a name I have selected. You can take any name of your choice. And here in this prime fact function, you can see the parameter int num. This prime fact function will actually receive some value. Okay, and that value must be the value for which we have to find the prime factors. Here, obviously, we are considering this example. That is why this num variable will receive value 450. After this, there is a requirement of some other variable. We have to divide this number by 2. That is why we need a variable to store this value 2. And here is how I have declared this variable. This is the pictorial representation of variable I. And you can see that the value of this variable is 2. Now what is the next step? You can see that 450 is divided by 2. Then 225 is divided by 3. Then 75 is divided by 3. And so on. This process is continuing. This means a loop is required. Of course, we need a loop. But it is not enough to have a single loop. We need a nested while loop. Okay. You can take for loop also. That is up to you. But here I'm taking nested while loop. Here you can see in the first while loop I'm checking this condition. Is num not equal to 1? If num is not equal to 1, then continue. Otherwise, simply get outside of this while loop. Why this step is required? You can see that I have added one more step in this prime factorization technique. In the previous presentation, we have seen this already, that we have to stop at this point. But I have added this one more step. Here I am also dividing this number by itself. And obviously if we try to divide a number by itself, then we'll get value 1, right? This is the quotient we will get eventually, right? So I've added this step for the purpose of simplicity, for the purpose of writing a simple program, okay? Here you can see I'm checking this condition. If num becomes 1, then we will get outside of this while loop. If num is equal to 1, then we should stop, right? This is the same thing. After this, we have another while loop, and this while loop is written inside this while loop. Here I'm checking this condition. If num mod I is equal to 0, if I completely divides this number, then we will continue. Otherwise, we will get outside of this while loop. Now, as I have said, if the number is completely divisible by 2, then we must push this particular element, that is this prime factor, inside the stack. There is no doubt that this is a prime factor, as this number is a prime number and this number completely divides this number. That's why this is a prime factor, right? Now it is not difficult to understand that if this number completely divides this number, then we must push this number onto stack. That's why there is a requirement of calling the push function, and to this push function we have to pass I. Correct? After this step, of course, we have to update our num variable. After this, after dividing this number by 2, we'll get this value 225, right? So we have to update our num variable by 225. This means num must be updated by num divided by I. Num divided by I will give the quotient, and we will store that quotient within this num variable. I hope the idea is clear. If it is not clear to you, let's see all the steps one by one. First, we will check this condition. Is num not equal to 1? You can see num is not equal to 1, so we'll get inside this while loop. Now, we will check this condition. Is num mod I equal to 0? We know that I is 2 initially. Is it true that when we divide 450 by 2, we'll get 0 as the remainder? Obviously, because 450 is completely divisible by 2, we will get 0 as a remainder. That's why we can get inside this while loop. Here, obviously we need a stack for the purpose of pushing this element onto stack. Here, this element will get pushed inside stack. After this, we have to update our num variable. Here, obviously, num must be replaced by num divided by I. Num divided by I is 225. Therefore, we will replace this value 450 by 225. The next step is to divide this number by 2. Again, we will try to divide this number by 2. Is this number divisible by 2? No, num is not divisible by 2, right? This condition is false. Therefore, we'll get outside of this while loop. And after getting outside of this while loop, we need this line of code, that is I++. We have to increment the value of I. Next time, we must divide this number by 3. And if this number is divisible by 3, we will continue and we will push this element onto stack. I hope the idea is clear to you, right? Now, the next step is to check this condition. Is num not equal to 1? You can see that num is not equal to 1. Therefore, we'll get inside this while loop. Here we will check if num mod I is equal to 0, then we will get inside this while loop, right? Num mod I is equal to 0. Therefore, we will get inside this while loop. And hence, we will push this element onto stack, right? This is one such prime factor of 450. I hope this program is clear to you. After this, we will update our num variable. This means now, num variable will store value 75, as you can see this over here, right? Then the next step is to check again. Is 75 divisible by 3? Yes, we'll get inside this while loop and we'll push this element onto stack. And then we will update our num variable by 25, right? After this, again, we will check this condition. Is num mod I equal to 0? Is it true that if we divide this number by 3, we will get 0 as a remainder? Of course not, right? 25 is not completely divisible by 3. Therefore, we will get outside of this while loop. And here, of course, we have to increment the value of I by 1. I becomes 4. 4 is a composite number, right? Let's continue. Let's check whether num is equal to 1 or not. You can see that num is not equal to 1. Therefore, we can continue. Here again, we will check. Is num mod I equal to 0? Of course, you can see that num mod I is not equal to 0, right? If we try to divide this number by 4, we will not get 0 as the remainder. Therefore, we have to get outside of this while loop. And here again, we have to increment the value of I by 1. This becomes 5. Again, we will check this condition. Is num equal to 1? If num is equal to 1, we'll get outside of this while loop. You can see that num is not equal to 1. Therefore, we'll get inside this while loop. We'll check this condition. Is num mod I equal to 0? Yes, this time num mod I is equal to 0, right? Therefore, we'll get inside this while loop and we'll push this element onto stack. After this, we have to update our num variable. This will get updated by 5. And then we'll continue with this step. Is num mod I equal to 0? Again, num mod I is equal to 0, right? Therefore, we'll get inside this while loop and we'll push this element onto stack. Again, we have to update our num variable. This becomes 1 after that. Now we'll check this condition. Is num mod I equal to 0? This is 1. 1 mod 5 is not equal to 0. Therefore, we'll get outside of this while loop. We'll increment the value of I by 1, right? And now we will check this condition. Is num equal to 1? You can see that num is equal to 1. Therefore, we will get outside of this while loop, right? And the execution is done. Now we have to print all the elements of the stack, right? For this purpose, we need this while loop. We will check this condition in this while loop. If top is not equal to -1, then print the element returned by the pop function. Or in other words, we can say that if the stack is not empty, then we will continue and print the value returned by the pop function. Pop function will always return the topmost element of the stack. In this way, we would be able to print all the prime factors of a given number in descending order. Isn't that simple? I hope this concept is clear to you, how to write a program to find the prime factors of a given number and print all the prime factors in descending order. Now, we'll see the complete code in code blocks. Here you can see the complete code. Instead of stack ARR, I have selected this name stack. Okay. Here we have is full function, is empty function, push function. We are already aware about these functions. I'm not explaining them over here. We have pop function. We have prime fact function, right? This is what we have seen in the lecture. And here we have this main function. Execution starts from the main function. Therefore, first this variable is declared. Then after this, we are asking the user to please enter a positive number. Okay. User will enter the number, will store that number inside this number variable. Then we will call the prime fact function for the purpose of finding all the prime factors of this number and print them on the screen, right? Here one extra line is added. That is, I want to print this message on the screen. Prime factors of the number in descending order are as follows. Let's execute this code. Please enter a positive number, say 34. You can see the prime factors of the number in descending order are 17 and 2. These are the prime factors of this number. This time, let's say I enter 450. You can see all the prime factors 55332. In this way, you'd be able to find all the prime factors of a positive number, right? Okay friends, this is it for now. Thank you for watching this presentation.